this on the camera there. There's you're going to print out the homework completion page. It's a PDF. You're going to download it and print it out, and then you're going to sign an initial, and then you're going to turn in that piece of paper. Okay, so you're going to fill out the PDF. You're going to print it out, fill out that piece of paper, and then turn in that piece of paper. Okay, so I'll have stacks for you to turn in your homework next week, and then I'll record it that way. So you're going to print out that form, sign it, turn it in. Everyone else good? Okay, then let's start with chapter 1. Okay, so in this, in our 12-week course, we're going to get through about chapter 9 in the book. Okay, so that means some of the later chapters are not covered, but that's about as much as we can cover in our time here. All right, so let's talk about statistics. Okay. So why do we study statistics? Statistics, all right. Well, the reason why we should study any subject is to help us understand the world around us. Okay? Study history to help us understand the world around us. We study physics to help us understand the world around us. Just every subject helps you learn about the world. They just offer different things. Okay? Statistics in particular subject statistics allows us to draw meaningful conclusions from limited data. Data is information. It's information that's generally organized and often puts numbers in a context. But all right. Let's talk about what limited data means. Okay. unlimited data. This is the reality of our situation. Reality, or yeah. Okay. And you know, we wish we could know everything. But we don't. Okay. So, for example, let's take let's say somebody asks you the question, what is the average lifespan of an American man? Well, how could we answer this? What is this asking? It's asking, how long does the American male live, okay? How long, what is the average lifespan? So, the only true way to answer this, to get the true answer, somehow we would need to know exactly how long every single person is going to live. Or, yeah, every single American male will live. And then, so if there's, 160 American males, or 160 million American males, we would need to know exactly how long every single one of those will live. And then what do? We add them all up, and we divide by how many we have. That's how we find averages, right? So, we need to know how long each of the 160 million plus American males will live. Add the numbers up. Divide by how many we have. Okay? Because that's how we find averages. Alright, the problem is we don't know how long each person is going to live. Okay? We can't predict the future at all. Alright? And even if we could, it would be extremely difficult to do that 160 million times. Okay? Two big problems. One, we cannot predict the future. So we do not know how long each person will live. to 160 million plus is too many people. Too many people for us to find. Okay. That would be if somehow we knew everything. This is what we could do, right? If we knew how long somebody was going to live, and we could do this for all 160 million people, then yeah, we could get the average lifespan of the American male. But we can't do this, alright? So what do we do instead? We work with human data. We cannot study all 160 million people. Okay. So maybe we can select a random sample. So instead, some randomly chosen people. Okay. Now this could work for other situations, but in our case situation where we're dealing with lifespan, we have to find out when somebody died. Okay, so now we're just dealing with records of death records. Okay, and in our case, and based on the information from the death records, then we can begin to answer this question. Okay? Begin to estimate average lifespan. Okay, but it's a challenging topic. population. The population is everyone we could possibly be interested in studying. Generally, usually, the population is too big for us to study everyone. It's usually too big for us to study everyone. So instead of the population, we have a sample. Okay. The sample is a group selected from the population. Is a group selected from the population, okay? Ideally, okay, and ideally, the sample is representative of the population, and therefore, by studying our sample, we can make conclusions about the population. Okay, so let's talk a few examples. Go over a few examples of what a sample, what would be the population. Okay. So think of these answers. Don't shout them out. Okay. So if I said. What is the average height of an NBA player? In this case, about what the population is to answer that question versus what the sample would be. Alright, so if we want to know what's the average height of an NBA player, the population would be all NBA players, okay? Okay, and there's quite a few hundred. Technically, we could study all of them, okay? Because we could list them out. But if it was too much trouble to measure the height of all NBA players, in our world today it's not, we might have to deal with a sample, okay? And what would a sample be? Okay, we would have to just select some people. Now, a team could be representative, but it might not be, okay? So a sample is just a selection of NBA players. Okay. So a team will not be representative, right? Will not necessarily be representative. Okay. Whereas, you know, a random selection might be. Okay. What if the question was, what percentage of homes or of households own a dog? In this case, maybe I should say what percentage of US households? Okay, what percentage of US households own a dog? In this case, what would our population be? All what? All households in the US or all households with dogs in the US?
All households with dogs.
All households.
The population is all US households. Okay, whether they own a dog or not, because we want to know what percentage of households own a dog. If we look at only all households that own a dog, the percentage will be 100% of all households that own a dog, okay? We want to know what percentage of households own a dog. We would need to look at all US households, and then we say, do you own a dog, yes or no? Some will say yes, some will say no, and then we'll get some number. 30% own a dog, or something like that, okay? Now, so this is all US households. Some will and some will not own dogs. Okay, but all US households, that's like millions of them. There's too many. So what is a sample? We would have to randomly select some households. Maybe we can randomly select 1,000 of them, okay? So perhaps find, you know, maybe 320. We find, okay, so we find that 320 out of 1,000 of these households own a dog, okay? So, what percentage of households own a dog? 32% of our sample own a dog. What does that say about the population? So we have a sample proportion or sample percentage is equal to 32%, which we did by 320 divided by 1,000. Okay, is that okay? So 320 divided by 1,000 gives me 32%. So 32% of my sample households own dogs, okay? So 32% of my sample own dogs. What does that say about all U.S. households? Alright. Okay, so does that mean 32% of U.S. households own a dog?
No.
No. Okay. What we're hoping, though, is that the sample of 1,000 households that I selected is somewhat representative of all U.S. households. Okay. If it's somewhat representative, or if it is representative, then that would mean that in all households, something around 32% own dogs. Maybe it's more than 32%, maybe it's lower than 32%, but something around there owns dogs. Okay? We can be pretty sure that it's not going to be 95% of U.S. households own dogs, and we can be pretty sure that it's not going to be 2% of households own U.S. households own dogs. Okay? We can say it's somewhere around 32%. Now we don't know if it's going to be a lot or little. It could be like 35% might be reasonable. Is 40% reasonable? Is 23% reasonable? Who knows? Okay, there's kind of this ambiguous range. All right, we'll learn more about later on. But right now, when we see that when we looked at 1,000 households and we found that 32% of that 1,000 own dogs, then that tells us something around there, something around that number own dogs in the entire United States. Maybe it's not 32, it's not necessarily going to be exactly 32%, but something around there, okay? So, I'm going to say 32% of our sample. Representative of the population, we expect that about 32%. Again, when I write the population there, we're talking about all U.S. households. Okay, so about is very vague. We can be pretty sure So if we find our sample has 32% own a dog, does 38% sound reasonable?
Yeah.
Maybe. Okay. We don't know, okay? 38% or 25%, okay? Who knows? Right? All we know is that when we found 32% in our sample, what does it tell us about the population? Well, we expect something around 32%. But at this point, we don't know how different the population might be from our sample. So that's the idea of making conclusions from limited data. Okay? We can't afford to look at the entire population, so we look at a sample, and based on that sample, we want to try to make a conclusion about the population.
What does it mean to be representative of the population?
What does it mean to be representative of the population? Okay. Yeah. What does it mean to be representative? That's a good concept. It means that ideally your sample is like a miniature version of the entire population. Okay. So the entire population is supposed to be all US households. Okay. If you select 1,000, ideally these 1,000 households could form kind of like a miniature United States, okay? So if, you know, in the US we have people from the East Coast, we have people from the West Coast, we have people from the South, from the Midwest, and all of these things. Ideally, each of those regions would be represented in your in your sample. We have, you know, the United States is pretty diverse, and you would want a similar amount of diversity in your sample. Okay, you would want that to be representative. So things, maybe I can give you examples of samples that would not be representative. Okay, so if we're talking about all US households, if we only picked 1,000 households from Texas, that would not be representative of the United States. Or if we picked 1,000 households from California, that would not be representative of the entire United States. Because if you look at California all by itself, it doesn't look like the entire country. Okay, if you look at Texas by itself, it doesn't look like the entire country. Alright? So representative just means that. Okay? Yes?
Or perhaps you selected households that go to veterinary clinics?
Well, not. That might be a way to help you get households that own dogs.
Well, that's what I'm saying. That wouldn't be representative because if
Oh.
you go to a vet, they obviously have a pet.
Right. Okay. Yes. Yeah. That will not be representative. Okay. Back in the day, if I, you know, getting a representative sample is actually very tricky. All right. If I said your assignment this week is to get a representative sample of 100 people from Los Angeles, you would not be able to do it. How would you do this? Yeah.
Select a few from each area in LA, like, you know, people here on the west side and people over in South Central or the Valley.
Okay. You'd have to, yeah, it'd be very challenging. Okay, you'd have to select random locations. Okay, you'd have to generate random locations throughout Los Angeles and pick people. And how do you pick people, right? Do you just say, I saw you on the street, you're going to be in my sample, okay? Would that, if let's say you were able to generate 100 random locations in Los Angeles, and then you went there, and then you took the first person you saw on the street, would that get you a representative sample? No. No, why not?
That person might not be from there.
It's a bias.
What would happen? What would happen is you would only get people who walk on the street, okay? So you would probably not get any old people that like to stay in their house, okay? Or I don't know. Depending on, you know, people who walk on the street is not necessarily the entire Los Angeles County, okay? Well, I'm trying to think when was the last time I went walking around on the street. It's only like to go shopping, right? Pretty much wherever I go driving, and then I just walk like 10 feet to wherever I need to go. It's just because I live a boring life, but you know, everyone's different, so yes.
Can you divide the number that your sample is going to be by region, and then add indexes to each region, and divide by that, and then select randomly like that?
Yeah, you know, selecting randomly is just gonna be tricky, okay? So anyway, we don't need to get into sampling just yet, okay? But it's the idea of getting a representative sample, all right? It's actually very tricky to pull off a representative sample, but a lot of these examples in our book, we're just gonna pretend somehow we were able to get a representative sample. Okay. With this, let's say. So over here I said, let's say we randomly selected 1,000 households, okay? What if somebody else said, oh, you found 32%, you know what, I want to try this experiment out myself. And they go out and they select 1,000 households themselves. Will they get 32% again?
No.
Maybe, okay. But is it possible for them to get 35%?
Yes.
Yeah, okay. Is it possible that they got only 28%?
Yes.
Yeah, okay. Is it possible that they get 70%?
Yeah.
I mean, technically it's possible, but is it likely?
No.
No, okay? So if one person randomly sampled 1,000 people or 1,000 households and they got 32%, if somebody else followed similar methods to randomly select people, it's technically possible, but extremely unlikely that they would get 70%, okay? If they got 35%, we'd say, oh, okay, that kind of makes sense. This other guy got 32%, you got 35%. That sounds reasonable, okay? But if somebody gets 32% and somebody else gets 70%, you'd be like, I think somebody messed something up, okay? And so we already have kind of this intuitive notion of what we call variation. How much can we expect these numbers to vary? 32% to 35%, that sounds kind of reasonable. 32% to 70%, that sounds unreasonable. Okay, but then there's a whole lot of gray area in between, and that's kind of where statistics and probability comes in, so we kind of can form better boundaries of where the gray area is. There was a question.
Do both parties have to retest their sample population, or how would you know which one was inaccurate?
Yeah, if one guy says, I swear I did everything correctly and I got 32%, and then somebody else says, I swear I did everything correctly and I got 70%, we'd have to go, something doesn't make sense, okay? And it's tough to say. Just based on that, you can't say. You'd probably have to say, well, how did you pick your 1,000 people or 1,000 households? And how did you pick your 1,000 people? And then we'd probably find something very different. One guy might be like, oh, well, I hung out at the pet shelter and surveyed 1,000 people. Okay, well, that sounds suspicious. Okay. And so, you know, every time, you know, you go online, right? And then on Facebook, there's all these terrible posts, and it's like, you wouldn't believe what 75% of Americans had to say about this, and like, click to find out, and you're like, what is this nonsense? But you click it, and then it's just something stupid. Well, you have to ask, well, how did they get the 75% or whatever? And you can look into the sampling methodology. Most of these sites will have no explanation of how they get this quote representative sample, all right? There's some trusted organizations that spend a lot of time trying to make sure they get samples that are representative, but it's very challenging to do. Okay? So when you see, you know, things published in the news where it says, you know, they get, they say, president's approval rating is this, you know, it's this number and it's always changing, right? Some days people like him, some days people don't. You know, how do they get these approval rating numbers? Well, what they're trying to do is they're trying to get a representative sample, and they ask, do you approve of how the president's doing, yes or no, okay? And based on those responses, okay, it's pretty much just like this, then they publish these numbers. And so that's often conducted by organizations like Pew Research and things like that, the approval ratings. And a lot of times they do random digit dialing. They just pick up, they have a robot, it just says, I'm going to spit out a sequence of random numbers, and goes beep, 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 and it rings, and it hopes somebody answers, and then they ask the question. Okay, so you have 2 minutes. Okay. We've already seen 2 types of variables, okay? This is an important concept. We have numeric variables, and we have categorical variables. Numeric variables are also called quantitative variables. Like a quantity. And categorical variables are also called qualitative variables. Like a quality. Numeric variables tell us how much or how many. Categorical variables tell us what type or what kind. Alright, so the height of a person is a numeric variable. It tells us how tall is someone, how many inches tall is this person. So height of a person is numeric. What else is numeric? Weight, okay. Age, these are all numeric. Okay, age in years, weight in pounds or something. Alright. Categorical variables.
Male, female?
Male, female, okay, so gender or sex. Sex is categorical. What else is categorical?
Single or married.
Single or married, alright. Relationship status. Eye color.
Ethnicity.
I'm sorry?
Ethnicity.
Ethnicity, sure. How about whether you own a dog or not?
Brand.
Okay, and brand, sure. These are all categorical variables, right? Okay, so you guys seem to have gotten the hang of that. It seems overly simple, the distinction between numeric variables and categorical variables. And it is simple. But sometimes when we do our problems or we take a test or something, we forget this simple, easy concept and then we freak out, and then we trick ourselves into thinking we're dealing with numeric when it's actually categorical, or categorical when it's actually numeric, so on and so forth, okay? You've got to be able to identify what's categorical and what's numeric, especially when it comes down to the final exam. Whether you are dealing with a numeric variable or categorical variable is very important, and if you cannot follow the right procedure, okay? If you cannot identify which one's categorical or which one's numeric, you shouldn't pass this class, okay? It's that important. You've got to know the difference between numeric and categorical. Okay? I think the thing that throws people off is, you know, a question like whether you own a dog or not is categorical, but you're going to still see numbers. You're going to see percentages like 35%, 320 out of 1,000. That's 32%. You still see numbers, okay? But it's a categorical variable because the underlying question is, do you own a dog? Yes or no. That's a category, okay? Okay, here's a question. Don't shout out the answer. Just think of it, and then we'll go over the answer in a couple seconds. Zip code, numeric or categorical? Okay, don't shout it out. Okay, now, zip code is that numeric or categorical?
Categorical.
It's categorical, alright? There's a number involved, okay? But it doesn't tell you how much or how many, alright? If the zip code here is, what is it, 90049, okay? Does that tell you how many or how much you have? No, it doesn't make sense to say, oh, I'm from zip code 90049 and you're from zip code 33457. I have, you know, 6,000 more zip code than you. I'm way awesome or something, you know. That it doesn't work that way, okay? You can say, you know, how tall are you? They say I'm 5'5", and then you say, oh, well, I'm 5'10". You can say, well, I'm 5 inches taller than you. I'm awesome, or whatever, okay? You can say that, okay? But in terms of zip code, you can't say that, alright? Or relationship status, you know, single or married, it's just a category, okay? Now we can turn numeric into categorical variables. We can turn categorical variables into numeric. But, so for example, so let me just say, sometimes we can turn So a classic one is age, okay? So normally when you say, how old are you? Or what's your age? You give them a number. I'm 23. I'm 45. You give them a number. Okay, I'm 17. Okay, generally this is numeric, but when it comes to legal things, the law, this is generally categorical, okay? You're either an adult or a minor. Okay, at 18 plus, you're an adult. Anything less, you're a minor. Okay, so we've taken a numeric variable, that's how many times have you gone around the sun, and we turned it into a categorical variable. Okay, are you allowed to vote? Yes or no? Well, I mean, that's more than just age, that's like other stuff, but are you considered an adult by the United States? Yes or no? Okay, if you're 18 plus, you can vote, you can go join the army, you can buy cigarettes. If you're a minor, there's things you're not allowed to do. So that's that. Okay, let's take a short break, like 10 minutes.